The webinar has started. The announcements just got posted to the Discord. I expect attendees to come in soon.
Brilliant.
Oh boy.
Hey guys, welcome to our workshop. We're waiting a couple minutes for some people to come in, just in case. But we will not really be looking at chat. But if you have any questions, please feel free to use the Q&A feature throughout the workshop, and we will get to questions at the end. We're going to start at like 4:05. All right, I don't see any more attendees coming in, so I think it's safe to start. So welcome, ladies and gentlemen. We are Penn State Game Design Development Club, and today we are going to give you a quick workshop for the intro to Unity 3D, and we're going to teach you kind of how to make basic games. So throughout the workshop today, what you will have is we will have a pretty simple slideshow where we explain the key features in Unity, how to use different components and scripting, and we will also have simultaneously a sample project that we apply all these features. The way it's going to work is we actually have screenshots of that sample project as we're working on it put in the presentation. And after we finish the presentation, which should take about 30 minutes or so, we will go in and we will delve deeper into Unity, into whatever questions you may have or whatever you want us to look into a higher depth. So without further ado, my name is Matan Botansky. With me I have Jonathan Tran and Alan Shu, and we will begin right away. So Jonathan will give us an introduction, and I will give more advanced stuff towards the end.
So first question, why are we even using Unity? Well, the main thing is Unity is pretty flexible in terms of what you can create. So Unity has the ability to create 2D and 3D games while also going across different platforms from PC to mobile. And not only that, Unity is actually really user-friendly. It has a really simple interface along with a lot of tutorials and forums that you can find online to help you along the way. And if you plan on working with a group and not just solo, Unity offers its own collaborative service. So you wouldn't have to use a third party like GitHub. It has its own internal collaboration.
All right, so this is a preview of the sample project we're going to make. So pretty much it's just there is a box and then you have 4 marbles in the box and you're rolling the marbles inside of the box to collect cubes that fall down. So this is just, it's very simple. Yeah. So to begin the project, when you first open up Unity Hub, you will click on a thing. It's like in this area, it says like create new project, and then this window will pop up where you can select the type of game it'll be. So we're doing a 3D game. You can decide on a project name and then where it will be saved to. And then once you've decided on all that, you click on create, which is here, and then it will create your project.
So the first thing that pops up once you have created it is this blank, I guess we'll just say a blank scene. And this is actually what it looks like when you open a brand new 2D game. But the only difference is that with a 3D game, it actually comes with a light component. And it would be in a 3D view rather than a 2D view. But here you can see all the basic things that we'll be going over later. So the hierarchy on the left, top left, the inspector on the right, and then our assets in the bottom. And so first we'll go over the object hierarchy, which like I said was in the top left. And it's pretty basic. It just shows you all of the objects that you have in that current scene. And it shows it by order of creation, which obviously you can change to alphabetical if you want. But yeah, pretty much anytime you add an object to the scene, it will also be added to that hierarchy list.
So to add things to the hierarchy, to like create objects, you right click, which will cause this menu to appear. And then what we're going to do is we're going to go to 3D object, and then we can create any of these. The floor and the walls, those are all cubes, but to make the players, which are the marbles, we're going to make spheres, which you would do by clicking on this.
And so now we're going to talk about the components of objects. So when you click on an object, all of its components appear on the right side, called the inspector, which is the picture on the right there. And all objects basically come with different components that you can add, and of course get rid of. And most of these components can actually be controlled by script as well. And so now on to scripts. So Unity uses C# as its language, which is extremely similar to Java. So if you know Java, it's a really easy switch over to C#. And so Unity uses these scripts to mainly change the states of these different game objects, as well as create functions for the different mechanics in your game. And Unity uses its own built-in functions and libraries as well to allow you to, help you control all of these game objects. And last thing is all of the Unity scripts actually extend the base class Manu behavior. And so any script that you make, it's going to extend that parent class. And then next is rigid body. Rigid body is a component that you have to manually add to your different objects, but it's essentially dealing with the physics components of these objects, whether it's 2D or 3D. So things like mass, drag, and most importantly, gravity. It's pretty much the easiest way to add gravity is just add a rigid body and then turn on gravity, and Unity already has its own built-in physics laws, which are fairly accurate. And of course, you can also modify and change them if you'd like.
All right, so this is a example script for the player that uses rigid bodies. So when you want to use a component in a script, you do public and then the component, and then you just give it a name. And then this is another thing you can do where you just take in a float. In this case, when you do public anything, when you go back to the inspector in Unity, a little window will appear where then you can either input the value you want or just drag in the appropriate component. So for rigid body, if we went back to the player objects and went to their inspector, you would see under the script component that a little window for rigid body has appeared, where then you can drag in the player's rigid body to make it work.
And so next is transform. The transform is pretty basic. It's just the position, rotation, and scale of the object. And most of the time, we don't actually mess with this component within the I guess, within the UI or the interface, other than just moving the object around where you want it to be. Most of the time, we're actually using transform in a script in order to control things like movement and other things like that.
So like here you can see we've created the sphere, and then we're adding a new component. So we're going to add the rigid body, so that way we can use it in the script.
And then next there's colliders and triggers. So colliders are essentially what allow different objects to collide with each other. And along with that, it allows you to detect when collisions happen. So then you can apply a function to that. So something happens when you run into an object. And then we can also use triggers to identify if objects collide to trigger events. So whenever you add a collider onto an object, there's a is trigger option that you can check and uncheck if you want. But essentially, whenever you make a script for this object, you use a function called onCollisionEnter or onTriggerEnter. And onTriggerEnter only works if the object that you're working with is a trigger. And so essentially, these functions basically automatically detect for you what if you're having a collision and what object you're colliding with. So using that, you can do whatever you'd like. And just to note that there actually are different functions for 2D and 3D. So for onCollisionEnter 2D, that would be only for 2D objects, and otherwise you would just use onCollisionEnter without anything after it.
So here we have a example of how to use onCollisionEnter in a script. This is the script for the blue cubes that fell down in the game. So you see here we have onCollisionEnter. So when this collides with an object, it first checks to see if it has a tag for players. So we want this to only go off if this cube collides with the player. And then when it does that, it contacts the level manager to let it know that it's been collected, and then it respawns at a new position, which is just this basically uses transform to appear at a random location in the cube, and then it uses the rigid body to apply a force in a random direction, so it will fall in a random location.
So now we're going to get into some more advanced stuff. So far, I hope you've been following along. It's fairly simple, and if you guys like, we can also attach the PowerPoint slides later for you to follow and on your own time. But moving on, we're going to go into Sprite and mesh renderers. Now, Sprite and mesh renderers basically impact the physical appearance of anything in the scene. Any object that has this component is visible, meaning that if you don't have this component on an object, you actually can't see it at all. So if you go to the next slide, we actually have a couple of examples of how we can manipulate this. So firstly, every object has a material. So what we can do is we can create a material and change it and then apply it to an object, which is what you're seeing on the left-hand side of the scene. Now, what we did here is we used the default Unity material, but we just changed the color to red so you can identify the player more easily. And then we dragged in that material from our assets folder, which we can show later on, into our materials tab up here in the mesh renderer. And then here we can also adjust many different things to do with lighting and probes and whatever. Usually this is not the kind of material that you use. This is just very basic material that we applied so that you guys can see. But Unity is actually fantastic for creating different materials and shaders with physics components and all that kind of stuff, which is very, very, which allows for a lot of creative freedom. And you can just generate stuff without even making them, especially in the last couple of years since they added the Unity, the shader graph feature, which you can look up later if you're interested.
So here we've in the project at this point, we've created 3 materials, which to do that, you would right click in this area and do a similar thing to creating the objects where on like the first thing that pops up, there's a it will say like create, and then you can create new materials. So I've created 3 materials, one for the cube, one for the player, and then one for the floor and the walls, which afterwards you can see I've done that. I've made the walls like and the floor a little bit shinier, and then the player is off screen, but I've also made the cube like blue at this point.
So everything you use in a game is called an asset. Basically what this means is it's every file that we use. You can see them in the assets folder at the bottom of the screen. You can also import them through wherever your base folder is on your computer. And you can basically drag these into the game and use them for different things. These include anything from models to sprites to scripts to fonts and anything you may use in your game pretty much. Many assets can be generated in Unity, like we said, textures and animations before, but also any sort of camera that you may use is also used in the same way. So a prefabricated object is actually an asset which is based off an object that we already made. This is how we can make recurring versions of objects in the scene without making them by scratch over and over again. We can actually drag an object that we've made from our hierarchy into our assets folder to create into prefab, which will retain all of its components and all of its preferences and details, so that we can instantiate it by script later if we need to. This is what's often done in games with enemies, NPCs, recurring buildings or items, and so on.
So here we've got an example of like the assets thing. These are 3 prefabs that we're going to use for the game. So we have the player, and then we've got pillars and walls, which are used to create the maze inside of the environment. You can see here that we've got a pillar and a wall here, and then by just taking these and dragging them up into the scene, we can just duplicate them over and over until we have a maze. And so we just duplicate them until we end up with this. So at this point, we're going to want to like test the gameplay. So to do that, we go up to this button, this play button, and we click on that, which switches this from the scene view to the gameplay view. So now when we're in the gameplay view, we can see that we're now looking through the perspective of the main camera, so wherever that is. And then also you can see that the graphics look different. And at this point, you can control the game as if you were playing it like actually. So if I use like the WASD controls, I'd be able to move the marbles around and collect the cubes.
So after you completed your game, it's very important to have UI, so you can have things such as title screens, menus, other details that you might want to show while you're playing the levels, such as score and currency and whatever you may be using. To do that, we actually use UI canvas objects. Now, every object that is visual, that you can see visually, that does not use an actual in-game component, uses a UI canvas object. Now, on top of this canvas, we can attach whatever we would like to use in order to create our menus and title screens. So in order to do that, we can implement things such as panels, images, buttons, text, and whatever, and so on. And then we can also adjust these using scripts using the Unity engine.ui libraries. Scene Manager is another library that we use. Scene Manager is effectively what we use to switch between different scenes. Most projects that you will make, you will have different scenes, and you can switch them in scripts by calling Unity engine.scene manager. And using this, you can switch scenes or restart scenes and so on. So yeah, that's pretty simple. We have a script example here coming up.
Right. So first, this is an example of the UI canvas. So we have the canvas, and on this canvas, we've got like the panel, the title, and then start and quit, which are 2 buttons. The panel is the white background that appears on the canvas. And then the title is this, where you can just edit the text for whatever you want. So in this, I just called it get 10 cubes. And then we have the two buttons, which are here. And then buttons have their own scripts that you can set to go off when they're clicked. You can see here, this on the left, we've got the text object, which here you can edit the text that appears, and then also the font, how it's aligned, as well as the font size and the spacing. In the middle here, we've got the button inspector, like the button components. And here you can see we're using this on-click here to have the button call a certain function when it's clicked. And this function is here on the right-hand side, this one. So you can see we've made two functions for the buttons, start game and quit game, where start game calls the scene manager to load the actual gameplay, and then quit game just quits out of the application. When you make functions that you want the buttons to call when they're clicked, you want to make them public, so that way when you go back to this window, you'll have this here appears, you drag in the script you want, and then from this drop-down menu, you can then see that we have the start game script, and we can select the start game menu from the drop-down. And then this is another instance of using the scene manager where we have the level manager, where once enough cubes have been collected, it calls the win function, which loads the title screen.
So now that you've completed your project, if you have UI and you have everything ready for a build, it's time that you can make one that's distributable to people that can play the game without actually having to use the Unity editor. So to do this, we just go to the top left corner. We can go File, Build Settings, and we can list the scripts, list the scene, that we want to use in our build. The scenes are ordered by a scene index. This doesn't really matter what your index is. However, the first object, the 0 index, will always be the first scene that loads up when you do the game, when you build your game. Of course, Unity has plenty of different platforms you can build your game to. Just make sure that you use the correct screen sizes and whatnot you may want to use. But you see, you can make builds for PC, Macs, Linux, Xbox, and all that kind of stuff, depending on what kind of project you're doing. It's simple as just creating a folder on your desktop and just doing a build.
And so now we're basically done with the project, done with the sample project. So this is once again just what the finished product will be like.
And so last thing is, if you're just working by yourself, or if you don't really, I guess, do a lot of art stuff, Unity Asset Store has its own assets that a lot of them are free, and then some are paid as well. But they just give you like different textures, different 3D models, or 2D sprites for you to use in your game to make make it easier for you if you're working by yourself, or if you're not much of an artist. And so you do that through the Unity Asset Store, along with importing them using the Asset Package Manager. And along with that, the Unity Asset Store actually has a lot of tutorials to help you along the way as well.
Right. Now, if you're a Penn State student, I'm assuming most people here are, we actually provide you a very good opportunity at our club to make games. So if you're interested in this presentation, which is nowhere near done, we will go into some Q&A and we will show you some more in detail stuff about the game. You have the option to join our club. You can do it by scanning the QR code here, which will lead you to our Discord server, and you can join. Everything's run through there. Basically, what we do is we split students up into groups at the beginning of each semester. There will be a simple sign up, and we basically have groups that are built of some programmers, some artists, some game designers, and together they end up making projects. So we have several of those running at the moment, and we will have many in the future. So feel free to join, and we're going to leave the screen up for a few minutes, and then once you have, if you would like, you can also leave a Q&A if you have any questions, or you can also just leave something that you're interested from the presentation, and we will also go and show you all those things in Unity later. So you go right ahead. We'll leave this up for a few minutes. Do we have any major questions? Anything that you guys would like to refer to back in the PowerPoint? Because I know we went through it really, really fast. We'll also provide you a link. I will actually do that in the chat right now, and you guys will be able to view what we are looking at. This is a copy of the slides. You can save them and refer to them later if you're making your own project.
Did you guys want me to go ahead and stop the recording now, or?
I mean, you can if you'd like, but if we're going to wait and see what people are interested in, and then we're going to explain things more in depth, depending on what they want us to cover more. Yes, and for those of you who have joined, we will let you. Someone in the club will contact you later. So I saw somebody had their hand up in the presentation. I actually can't see who it was, but you can feel free to use the chat to ask your question. I can't actually enable your audio.
I can enable their audio. 1 second. Okay, Elliot, you now have permission to talk and ask questions.
Okay, hey. This might not be on topic for like going back to the other PowerPoints, but do you like to use like other stuff like Blender to do your rendering, or do you like to do everything in Unity?
Okay, so Blender is actually the #1 tool that we use when rendering stuff and bringing in 3D models. This presentation was solely based on the programming aspect of Unity and actually putting together the games. But yes, all of our 3D groups mostly use Blender, and as well as some other programs to create their models and render textures and materials and whatnot. It is free, and Unity works with it very, very well.
Okay. So are there any are there any 3D rendering capabilities inside of Unity besides those assets that you can import?
Well, the Unity 3D rendering. Okay, so we render 3D objects in Blender, but Unity later, when we import those object files into Unity, Unity will know how to read them and play them exactly as they would look in Blender, and then Unity is also where we assign all the different lightings and stuff. Unity, however, does have some features that are also in Blender. For example, shader graph, as I mentioned before, is an interface that we can use in Unity to create shaders. It's node-based. If you have familiarity with Blender, it's pretty much the same thing, but it's directly done through Unity. So hopefully that answers your question.
It does. Thanks.
Yes. Does anyone else have any questions directly? Because if not, we can go in and we can show you the scripts more in depth, right, Alan? Do you think we can do that?
Yeah.
Yeah. Okay, yes. Are the slides available anywhere? It is the link that I've just attached here. Should get you to the slides.
And then this presentation will be posted later on HackPSU's YouTube as well.
Oh, you don't? It's in the chat. The link. I don't know. Can you guys see that? I'm being notified that they can't see the slides.
Oh, yeah, 'cause
If you
I-
click the link, it should take you to the Google Doc. It worked for me. Oh, you sent it to all panelists.
Okay, my bad.
Yep, that was it. Sorry, guys.
Let me generate the link again. We can move it on. My mistake, guys. I apologize. There we go. Here's the slides. Does it work now? Yep, okay.
Yeah.
Alan, do you want to play your game, and do you want to play the game a little bit in live?
Yeah, I can do that. Should I go to the title screen and do that, or should I just do it?
Yeah,
from
probably.
This view? Okay, yeah, let me do that. It's basically like what we did in the thing. When you're in the Unity view, the quit application doesn't actually do anything because we're not in an application, but start will load the scene and then it will play the game.
So you're just using arrow keys and
WASD. This could also work with the arrow keys. That's not a super difficult change to implement.
And in case you can tell, the balls actually move all in the same direction based on the key that you press. So it's as if like you're tilting the entire, I guess,
You're
playing
tilting
field.
the box and rolling the balls inside it.
Yeah, so Alan, do you want to go into the script that moves around the balls, and we can actually go really in depth into how we did that?
Yeah, let me load the scene again, and then I just go to the player. If you see down here, I have the controls script, where if I double click on this, it will open Visual Studio, and then we can go in and take a look once it loads.
Do you want to explain it, or do you want me to go through it?
I think I can give it a go, and then if I miss anything, you can fill in, right? So we use input.getKey to detect like the player's input, so just WASD, and then this applies a force in the appropriate direction. This speed comes from this, where if you go into the Unity editor, you see right here I've got a speed value here, so I can input whatever speed I want. So if I change this value to 1, and I load the scene again, then now the balls move, or now just the specific ball that I'm interacted with, which is the player, you can see that this one moves much slower now because it applies less force.
And that is specifically because that value is public. If it was private, that would not be there, and you wouldn't be able to control it from the Unity interface.
Yeah, making the values public makes it easier to go and edit them, because if this was private, then every time I wanted to change it, I'd have to go into the script, change the value, and then save, and then like recompile it.
So somebody asked in the question that's kind of off topic, but they said, what is the difference between Visual Studio and VS Code? Well, pretty much VS Code is just an editor that allows you to edit many, many, many different languages, while Visual Studio just has some different features. Visual Studio actually comes packed with some different features to specific languages that Microsoft focuses on. So like C#.NET is something that Microsoft actually runs. If you go to the documentation, it's all Microsoft. So Visual Studio has many features to run and edit code and debug things in those languages. Also, Visual Studio comes in package with Unity. So because Unity uses C#, it is probably the best editor you can use. So that's pretty much as far as I can go in explanation. Hopefully that satisfies your question. So yeah, if you just want to walk us through more scripts, Alan, and we can explain.
Yeah. Oh, then also with what I mentioned, but the rigid body earlier in the PowerPoint, you can see that this window is where the rigid body would go. So all I have to do is just take the rigid body from the same component and drag it in like that. We can go into the cube next. So I just do the same thing. So we're in the cube script now. So first thing, I guess, is the spawn, where you can see in this start function, which the start function will be called as soon as the scene is loaded. So anything that's in here goes off just immediately upon starting the scene, and then whatever's in the update gets called basically every frame. So if you go back into the player controls, you can see that these are in the update function, which means every frame it's checking for these inputs. So back to the cube, we see on the spawn that we use random.range to generate a random value that's within this range. So this here I just set as like -8 and 8. And then I set it to spawn to set y height and then a set, and then a range in the z direction as well. And then
Can I
once
stop you for a minute?
Yeah.
Yeah, so notice, guys, this is actually uses a vector 3. Now, a vector 3 basically is a tuple, pretty much, that uses 3 input values that are either integers, floats, doubles, whatever kind of number system you would like. And Unity actually uses these vectors a lot when it comes to positions or physics. This is actually probably going to be the data type you're going to be using most often when making a 3D game.
Yep, we can see for the add force, we also use a vector 3 as well. So like we apply force in the x direction, the y direction, and the z direction.
Okay,
And
now
then
we actually got a Q&A.
Yeah.
Hi, we got a question. Hello, I'm not a PSU student, but I'd like to try and bring a game design club to my school. Does Unity support any other languages such as C#? If so, do you use languages you're more comfortable to make games? Okay, so the answer here is mostly no. However, Unity primarily does use C#. However, what I would say to that is there are different platforms that are a little bit harder to use, I'd say, such as let's say Unreal Engine, which uses C++, but they're more difficult to use. So primarily, Unity does use C#. I know most high schools in the United States do teach AP Computer Science, which is in Java, and so transitioning to C# is very, very, very quick to use. Microsoft has great documentation for the language, and Unity has fantastic documentation, some of the best I've seen for the Unity functions. So you can have a deeper look into that. There are occurrences where we use other scripting languages in Unity, but not to do primary things, to do more in-depth variables and AI stuff. So I personally have experience using a little bit of Python and Lua in Unity, but it's not very common, I'd say. So yeah. Do we have any other questions? If not, Alan, you can continue.
What else should I go over? Let's see.
If you want, you can go back to the scene, and we can go into cameras a little bit.
Yeah, I can do that. So in the scene, I've got the camera here. For some reason, I can't like change the perspective, which
Zoom in in the scene.
Zoom.
Oh, you're locked in 2D. That's why.
Oh, I'm locked in 2D. That's why. Yeah. And pretty much any scene you can go in a 2D view, which does that. You just uncheck. You just click this button to switch between 2D and 3D views.
That's very easy. That's very helpful if you're trying to do stuff with UI, because UI is always 2D.
Yeah. And then when you're in the editor, you can use these buttons here to switch from what perspective you're looking at the object from. And then if you click the center of whatever object, if you click this again, it changes to a different view. I think this is like orthogonal. Yeah, orthographic.
Orthographic, yeah.
Yeah. So you can use this to switch between perspective and orthographic views. For the camera is in perspective. So this camera just is how this camera is basically what we see the game. If we move the camera, you can see down here in the camera view that it's like the view of our view of the game is changing based on that.
And that's pretty much what you see when you see games with different camera angles. That's pretty much what gets used.
Yeah.
Is there anything else anyone's interested in specific? We can go into anything really. We have the full complete project. Another item that we have here that we didn't really mention is lighting, but I think this is pretty straightforward. Every Unity scene that you create will have a direct light component that is automatically generated. It is very, very straightforward. We just selected a light color and a lighting type, and it just creates that kind of light. This is usually how people make like sunlight in a game and so on.
Use the light so it doesn't create a harsh reflection on the floor surface.
So the floor surface, it was actually just an example. It was just an example of the material that we used when explaining stuff. So what Alan did, he increased the smoothness on the floor to higher than the default level, I believe.
Yeah. No, I increased the metallic to
the
higher.
Metallic. So if he changes that, that's actually the material rather than the light. But we can also do different things to the light as well.
Yeah, I can also go and like, mess with the intensity as well. If maybe, let me get a better thing. Like I can do that, but then that, like, you can play around with it. You can also just change the type of lighting, because like I have it as a point lighting, but if I change it, I can change it to other things. Directional light doesn't really work for the type of project. But like spotlight can also work as well, since it like generates and just spotlights downwards.
So how do collisions work if we're using custom shapes? So there's actually two different custom colliders that we can apply to custom shapes. So for example, so it actually differs if you're using 2D or 3D. When you're using 2D games, there's a polygonal collider which creates a custom collider based on the custom 2D shape. It uses kind of like a mesh. Same thing applies to a mesh collider in 3D, which usually creates a mesh surrounding the model that you're using, and that's how the system knows where the collider boundaries are. But regular objects, we have sphere colliders, capsule colliders, sphere colliders, terrain colliders, which we can apply to terrain maps. That's a little bit more advanced, but you can see here's Alan's pulled up an entire list that we can use for different objects.
Yeah, the one thing is that with custom shapes, generally you want to find just a collider shape, like one of these stock collider shapes that would best fit it, because using the mesh collider is a bit more intensive on the system. So if you can, in like instances where you can just use like say a capsule or a box instead of the mesh collider, it's generally preferred to do so.
Although if you really want to use a mesh collider, you can make a convex mesh collider that kind of adjusts the mesh to make it a little bit less intensive.
Yeah,
What is the coding ratio to the Unity? So I'm assuming that you're asking about how much coding we do rather than actual editing. And I would say that this depends on the amount of, it depends on really what you're trying to do. If you're doing something that's more, if you're making a simple game that's more dependent on its assets and sprites, then the coding will be lesser. But if you're doing something that uses a lot more physics and a lot more mechanics, then you would probably have more code. I would say for the stuff that I do, and I work a lot of procedural meshes and stuff like that, I use code for 80% of my runtime, and 20%, the rest of it is just adjusting different components that I've created myself and so on.
Yeah, I think that's pretty accurate, especially when most of any mechanics you really want to add to the game, you're going to have to script it. There's not really any specific game mechanics that you can add just by using the Unity editor. In my mind, I kind of feel like the Unity editor is just for looks, and then anything behind the scenes is all script. So I would agree with like the 80-20 ratio.
Yeah, and also if you struggle to code, you can get different templates online from various sources, including the Asset Store. There's several other websites where you could do that kind of stuff. I'm going to have one more question, and then we're going to show the club entrance slide. Okay, so let's see. I want to create a 3D character for a game I am creating, but my team does not have an extensive technical background. Software like Figma and IBM Watson is mitigating the need for code to develop an app. Do you know any game development tools beside Unity making similar headway towards no code or low code? Well, I would say the other major public one is Unreal. But again, most games, if you want to make a proper game, then you would have to use a lot of code. Otherwise, they would be very, very easy to build. Yeah, I don't really know how else you would make a game. Yes, we have a asset subreddit if you're interested in the chat. Assets, you can also get many free assets on the asset store. There's the Bracky's website. If you've been to it, let me try and link it here in the chat. He actually has a lot of very basic tutorials. I mean, they just retired their YouTube channel, but they have free assets and tutorials that you can use. I will also link this in the chat right now. Yep, and we are coming up on time here. So Alan, do you want to switch back to the club slide? And
Yep.
You guys have a last chance to. There you go. So if any of you are interested, you can feel free to go through here. Yeah, there are a lot of incredible people in the community. Unity has really grown, and it's probably the most used engine. And you can find tutorials online for anything, really, that you can adapt or use directly in your games. There's no need to reinvent the wheel every time. So yeah, that's our presentation. Hopefully you guys enjoyed. We're going to leave this up for those of you who haven't joined the club. But thank you very much for coming. Feel free to save these slides, and I know there will be a published version of this on YouTube at some point. But yeah, it was great to have you, and thank you, HackPSU, for letting us go again. So hopefully we'll be back at some point.
Yep. Thanks a lot for attending, guys.